One of the mantras that I often repeat here is that all ideas are not equal. There are bad ideas and good ideas in software development and everywhere else. But in software development, we should be able to distinguish between them. I talked about Carl Sagan's baloney detector in a recent video as one way to identify the bad ideas. One of the ideas that I often use as an example of what I think is a terrible idea when it comes to software development is that of the waterfall model. Adopting this as an approach is a terrible mistake, yet it's still at the heart of nearly everyone's approach, even if they don't recognise it as such. So what is waterfall development really? Why is it quite so bad, and how on earth does it manage to still be seemingly the default approach despite being demonstrably so ineffective? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. And if you haven't been here before, please do hit subscribe. And if you enjoy the content here today, hit like as well. Let me begin by making my position very clear if it's not already. I think that there are no circumstances, zero, where waterfall is the best option for development. It isn't what works best for regulated systems. It doesn't make safety critical systems safer. And it isn't what we need to be able to do to organise large-scale development. It's not what organisations who are best at any of these things in software do. And of course, it's bureaucratic overkill for anything else. It's a terrible idea that will always result in a worse outcome. That doesn't mean that you can't build software, but your chances are lower that you're going to succeed. But despite all of that, it's still what most people in some form seem to choose to do. And fundamentally, I put that down to the lure of the plan and the illusion of rigour. It feels as though we're working harder when we're working that hard. First though, what do we really mean by waterfall in the context of software? I think that most people watching this will have seen in some form this diagram. It's probably one of the most used diagrams associated with software development. But the weird thing is that it's a mistake. The idea of decomposing software into a series of distinct phases was originally proposed in the 1950s. But the commonest description that most people reference is this, the paper written by Winston Royce, published in 1970, which is where this diagram comes from. This is a 10-page document, and this famous diagram appears on page 2. So one exploration for the popularity of this terrible idea is that people in the 1970s were too lazy to read the whole document. Because if they had, they would have learnt what Dr. Royce really thought, which was that this approach is risky and invites failure. Royce's document was written around this diagram as a straw man, which he then proceeds to dismantle. As the document progresses, Royce identifies many of the holes in the waterfall approach. What Royce is actually proposing is certainly no lean or agile nirvana either though. It's pretty bureaucratic in itself. But there are, interestingly, several strong recommendations that to modern ears at least sound remarkably close to what we'd think of as an agile approach to development, including heavy reliance on integrated testing as part of the development approach. If you'd like to learn more about what we have learned how to do better in the last 50 years, check out my free Continuous Delivery Fundamentals course. There's a link in the description below. Despite this early identification of the flaws of waterfall in the context of software, this naive, overly simplistic take on what it is that we do and how best to organise ourselves to do it seems to have become the default starting point for many, if not most, software development projects over the past 54 years. Whatever terminology people choose to describe how they organise things, most organisations would still claim not to be doing waterfall these days because it's out of fashion. But even so, they continue to try to analyse, plan, design and estimate all the work before they start in a distinct series of phases, and most organisations leave testing as the last thing to do before they release, all of which sounds an awful lot like a waterfall to me. I think that the key practical test of whether or not your development process operates this way, as a waterfall, is how well it works when things go wrong. How easy is it for your organisation or your team to change the requirements if something is wrong with them? Or to change the plan if you think that something more important is what you should be doing right now? How easy is it to detect that a design, architectural or product choice is a mistake, and how easy to react to that knowledge and change direction as a result? It's this ability to change our minds that represents the agility implied by the word agile. Let me pause there and thank our sponsors. We're extremely fortunate here on the Continuous Delivery channel to be sponsored by Equal Experts and Transfic. Both of these companies are great friends of the channel and offer products and services that are very well aligned with the topics that we discuss here every week. So if you're looking for excellence in continuous delivery and software engineering, please do click on the links in the description below to check them out. I suppose that the appeal of Waterfall is kind of understandable. It's popular because it's easy to understand, even if it is completely wrong. And it seems to me that it's hard to argue that it is anything but wrong, though lots of people try anyway, which is why I suppose I'm making this video. The first and biggest flaw that Royce himself pointed out in his paper is that there's no feedback, and so no opportunities to learn. In Royce's words, the implementation described above is risky and invites failure. The testing phase, which occurs at the end of the development cycle, is the first event for which timing, storage, input-output transfers, etc. are experienced as distinguished from analysed. These phenomena are not precisely analysable. The next step that Royce recommends as a result of this is to allow for feedback between the steps. He recommends that this should ideally be limited to feedback only between adjacent steps or adjacent phases. So if at the point when we are writing some code, we discover a problem in the design, we can feed back to the designers, but if that design problem was as a result of a problem with earlier analysis or with the requirements, we coders can't get to feedback to those groups of people. The designers can, but now we're feeding back a half-translated, probably misunderstood version of the problem via a game of Chinese whispers to groups of people that don't know anything about the reality of the code. And then we will need to effectively rerun the whole waterfall again with this new information, because our suggested changes may have had wider implications. Royce goes on in his document to explain why this is wrong and really doesn't work very well. Culturally, socially, it's even worse than this though. By organising things this way, it seems to me inevitable that the downsides of bureaucracy will infect this process. Remember, we have decided to divide up the work and the people into a kind of production line, with each part consciously distinct and focused only on their local part of the problem. So inevitably, when the developers find a problem and raise it with the designers, you can guess the first response of the designers. You misunderstood, you're doing it wrong, that's not what we meant at all. So now there's a lengthy debate with everyone upstream pointing out that everyone downstream is an idiot and didn't really understand quite how brilliant their work really was. Even if this process was to work perfectly though, it would still be slow, cumbersome, inflexible as a process. But I'm afraid in my personal experience, it's actually usually quite a lot worse than even that. To the extent that what actually happens is that people don't even bother trying to feed back to earlier stages because it's such hard work. Instead, what they try to do is to patch over the problems that have flowed downstream based on their own role, skills and tools and experience. But this means that what might have been a very easy problem to fix if we'd fixed it in the right part of the process might have become difficult or even impossible to fix at the point at which we try to fix it. So the code diverges from the design diverges from the analysis, and all no longer relate directly to the requirements and so on. The reason that this process is called a waterfall is because ideas flow much more easily downhill than they flow back uphill. So feedback is somewhere between difficult and impossible to deliver effectively. Usually meaning that we only get to find out how bad the system really is once it hits production. So what we really need to do better than this is to make progress in much smaller steps and to re-evaluate everything, requirements analysis, design, coding, operations, and so on after each small step. Sound familiar? That's the most profound fundamental change that Agile approaches promote. Work in small steps and reflect on what to do next after each small step. This matters because it allows us the freedom to make mistakes, the very freedom that Waterfalls denies us. Freedom to make mistakes may sound like a rather odd thing to want, but without that freedom, learning is essentially impossible. Given the very strong preference in direction implicit in Waterfall, it seems evident to me that the only way that this works is if you know all of the answers at the start of the process. For Waterfall to work, we need to begin by getting the most important things right before we even start. Waterfall starts from the assumption that we know what we need to achieve. We know how to organise ourselves to achieve it, and we know what we need to do to achieve it. And we must execute on all of these things well enough that nothing significant goes wrong, at least not wrong enough to disrupt this downward flow. This is like no successful software project that I've ever seen or heard of. In fact, it seems to me that it completely misses the fundamental nature of what it is that we really do. Namely, that software development is a process of learning and discovery. Waterfall works when you know all the answers before you start. And so is a terrible fit for software, because if we had done enough work to know all of the answers, we'd have the code that did it, because that's how fine-grained you need to go to know all the answers. If we had the code, we could simply copy it rather than rewrite it again, and so there'd be no software project at all. Waterfall depends on the overconfident view that we can get things right from the start without doing all of the work. But even if that were true, while we took time to build the software, the world around us would have changed, and so the software would now be wrong in the context of that new world by the time we were finished. Agile, on the other hand, demands that we assume that we're almost certainly wrong at the start. This radical change in focus allows us and encourages us to correct things and to work in a way so that those things, when they do go wrong, don't break the whole system. So it's by far the more stable, rational approach. It's based on learning and feedback, experimentation, rather than on overconfidence. Waterfall assumes that what we need is a production process, when in reality what we need is to be good at problem solving and at design. These are very, very different kinds of activity. So if Waterfall is such a terribly poor fit for software, why did it end up being quite so popular? In part, it's because it makes sense for a well-understood, constrained, comparatively simple problem. And some problems in other fields of engineering are like that, or at least more like that, where the production phase is a difficult thing. But this is never the case in software, and the economics of software development mean that it never will be the case, because the cost of production in software is essentially free. We can clone any sequence of bytes, no matter how complex, for essentially zero cost. So the hard part in software is not the production of the result, because that's just the cloning the bytes. It's the identification of the problem and the design of the solution. This is the civil engineering equivalent of building a brand new kind of bridge or dam from a material that's never been used before for bridges or dams. And when engineers do things like that, then they don't follow a waterfall process either. They do what design engineers always do. They experiment, proceeding in small steps, gathering feedback to help them to learn. In some ways, the lure of this naively simplistic view of the development process is, I suppose, kind of obvious. If you or I wanted some software to achieve some goal that we had, and we were going to ask somebody else and pay them to make it for us, then of course we'd like to know how much it was going to cost and how long it will take. But the unavoidable truth here is that we can't answer either of those questions for an exploratory process based on discovery. This shouldn't really be surprising to people, but for some reason it does seem to be. Look at any large project of any kind, software or not, and you'll see estimates there that bear no relationship to reality. Delays and cost overruns everywhere. HS2 in the UK is a good example. That's because we humans are useless at predicting the future. I am currently getting quotes for some work to rebuild chimneys on my house. The builders are happy to estimate for two of them and refuse to estimate for the other because they don't know enough about what's involved in fixing that chimney. This isn't about software, this is just about some things that are hard to predict and others that aren't. Software is nearly always hard to predict because if we aren't doing something new, we're doing it wrong. The answer is to make progress in deliberate, small, controlled steps, evaluating our decisions and our progress towards our goal after each small step. This may not be rocket science, but it is science, or at least its practical arm, engineering. Thank you for watching. And if you enjoyed the content here today, please do consider supporting our work here on the Continuous Delivery channel by joining our Patreon community. There's links to that in the description below too. Thank you, and thanks to all of our patrons for your existing support.